Hello guys, I'm back. My name is Jeferson Costa. I'm a chemical process engineer with expertise in plant design, and today I have as a guest to my live session Harvon Yao. He is from China, he lives in Shanghai, and he will share with us a little bit of his knowledge about cryogenic air separation. It is a pleasure to have you here, Harvon, because I know that in Shanghai it is Saturday evening. In Brazil is morning, but you should be with your family, enjoying your weekend. But you are with me here to help more chemical process engineer to understand how is the roles and challenges of working with chemical process engineering and plant design. I would like that you present yourself and in general terms tell to people what you do, and I will invite people to tell us where are you from and participate because your question can be addressed to Harvon during this presentation. So Harvon, it's up to you.
Okay.
Feel free,
Hello.
feel free to start. Please present yourself, what you do.
Okay, sure. Okay. Hello, everybody. And I am Harvon. I have worked for an air separation company about more than 9 years. Very happy to share the experience to you today, which you will enjoy. Okay, Jeff, for you.
Okay. I'm sharing the link to this presentation with the people in LinkedIn and
Jeff, you
also,
are mute.
oh, sorry. I'm sharing the link of this live session with people in LinkedIn and also the Facebook, and finally to people that follow me at the Telegram, because I have a Telegram to help people to understand what is the role of the chemical process engineer in plant design. And that is set. And let's see if someone answer to us where are they from. So we have people from India. We always have people from India. It's very nice. They are very interested in chemical engineering, plant design. And I will start with the first question. And I have a questionnaire here to address questions to you. And my first question, Harvon, is I do this question to everyone that is my guest in this live session is how to was the transition of your to be of being a graduate to be a chemical process engineer, and how did you get your first job?
Okay. Um, Actually, it's my 10th years working the current company, and it's my first company after my graduation from university. However, I was different positions in this one company. So, go back to the transition of the first job. At the beginning, I had already gotten an offer from a very famous and large company. But when I was informed that I was accepted by the current company I work in, I gave up the famous company. That's a famous and large company without hesitation. Because there's more opportunities to learn and to get knowledge in my current company. So it's also advised to the fresh graduates pay more attention on skill increase and when you choose the job, and take less focus on the salaries, and in the future you will get your payback or salaries, and after you get experience in a company, which company can give you more opportunities and more chance to improve your skill.
What kind of questions you faced when you you go to the interview to get your first job? What kind of questions usually you need to be prepared to answer?
What's the sorry? What's your question? Yes.
When you did the interview for chemical process engineer, your employer did some questions to you, or it was an interview, it was a test, how it was?
I remembered actually there were like a diagram, a function diagram showing the ASU, and the interviewer will ask you, do you know what's the diagram, and how can you tell some things in that diagram, and what's your thinking about this diagram? And it's focused on skill, but actually most of the others for fresh graduates, it's the it's the interest, you know. When you are facing an interviewer, and you will know this is very interesting. This guy is very interesting in the kind of like air separation.
Nice. Nice.
Okay.
And in the fact, your first position was in the automation area, not in chemical engineering, right? And
yes.
Why did you change it from automation to chemical engineering, and how the automation helps you today doing your job?
Yes, I joined my current company as a programming as a control system engineer, and after maybe I remember it should be 4 years, I transferred to process. Actually, my major is chemical engineering in my university, and it is very helpful for control systems during the work, because actually the control systems in air separation or in other chemical engineering factory, it is help and support to process requirement. The core is the process knowledge. So you know there is a position named APC, means advanced process control. It combines the control system knowledge and the process knowledge. So my advice is to this year, think more about the reason when you are doing the programming. For me, and I will doing the process thinking when I am programming, you know, and you will know the details about the process, how to control a valve, or how to control equipment, a compressor. When you are doing the programming, it will be very helpful for the understanding, because I am process engineering. I major in process when I in university, so it's very helpful. And after that, the focus is process and the core is process. So I transfer to process. This experience in control system helped me a lot to transfer this position, and I can get more detail and more more knowledge when doing the process. That's all.
To prepare yourself to understand better, let me do the first question related to process now. Now we know you a little bit more. And what is cryogenic air separation in general? After that, I will share with you a block flow diagram to explain to people that are with us. But in general, what is cryogenic air separation?
Actually, it's industry process, and compared to other chemical factory or chemical plant, the air separation unit is focused on the heater exchange and the mass exchange. It's a cryogenical, so it's related with the heat, the cryogenic liquid. And the main components of air separation is air compressor and turbine for the regeneration, refrigeration. And the most important of air separation is the coolant for distillation. Normally we will call it as cold box. And after that, we will have several products like gases, oxygen, and gases, nitrogen. And for the newer technology, normally we will use internal compression for gases, oxygen. And for the gases, nitrogen, we will have maybe a outer compressor to fuse the compression to the pressure you want to get. And except for the main plant of the air separation, normally we will also have a backup system. It's another configuration. Today we will focus on the air separation unit, right? So I can say some details about the normal configuration for a ASU plant. So Jeff, maybe you can show a picture.
Yes, I will share with you the picture. And guys, just to remember that we are doing here general information about the process. We are not supposed to mention
Jeff, you are mute.
any... sorry. Guys,
Okay.
just to remember you that we are talking about general process. We are not supposed to share any kind of information related to companies. So that's why I didn't ask Harvon where he works, because it's not the matter here. The matter is process and career. And I will share with him right now the block flow diagram, and he will explain with as much detail as possible the air separation process.
Okay.
Okay, Harvon, I think that you can get control.
Yes, sure. I can see your screen.
Are you able to move? Are you able to move my mouse?
Let me check. You can give me the control or not?
Yes, let me see how I can do that.
Okay.
I should give you, or you should ask?
You should give me, I think.
Yeah, I'm not able. Just a moment. Okay. Now, did you get it?
No? Okay, that's no problem because it's not too much complicated. I can just saying and with your mouse move. Okay.
Okay.
Okay. Yes. Yes. Says you are stopping on the air. Let me begin at the first beginning. And you can see this is the overall and the generic air separation function diagram. And the mouse stopping is on the MAC. The MAC means the main air compressor. And it will suck the air from the ambient to the compressor. And after the compression, the pressure of the air will be compressed normally like 10 bar. It depends on the process. Normally we will say it at 10, maybe 10 bar or 5 bar. And after this compressor, we will go to a pretreatment skid. This is actually this will normally will include different units like chiller. If you need make this air into a pre-purifier to remove the hydrogen carbon or remove the CO2 and the water inside the wet air, because after you get this hello?
You're back. You're back.
Okay. You need to remove the hydrogen carbon and the CO2. After the pretreatment, just you can see on this diagram, there's two streams. One is to the expander, and another is to the main exchanger. Let us to talk the expander first. For the expander, it's the refrigeration creator from the expander. All of these plants, the refrigeration is one of these is from the expander. Another is the heat exchange in the main exchange. Okay, after the expander, there is a cold air into the column. For this stream, it's going to the low pressure column. Okay, and besides the cold box, let's talk about another stream first. From the pretreatment, it will go inside of the main heat exchanger. Then with the exchanger by the liquid oxygen or the cold gaseous waste nitrogen, it will go into the, normally it's a pressure column. Okay, so this, normally we will have this several stream. On this paper, two stream into the column from, and another two is from the cold box to out of the exchange. And we can talk about the cold box first. You can see there's two parts of the cold box. The lower is the pressure column.
Okay.
Jeff, you can move to the HP column. Is okay. Here. This is the pressure column. The pressure will almost same as the outlet of the MAC outlet pressure. And on the top of the pressure column, it's low pressure column. And the low pressure column, the pressure normally will be very lower for the general air separation. It will almost like 10 kPa. And in the middle of the low pressure column and the pressure column. It's main condenser. In this part, the liquid oxygen will be produced. And this part almost is the most critical part of the whole of the air separation, because the hydrocarbon and the CO2, which is not fully removed in the pretreatment, will accumulation in this part. So you need to take care about this one. If these two, like CO2, like hydrocarbon, accumulate in the liquid oxygen, maybe it will explosion. So it's very dangerous and you need to care about it. Okay, let's continue talk about the process. And then you can see the red one from the main condenser. When after the main condenser outlet, you can see one stream is back to the top of the pressure column. It's a reflex nitrogen. And another stream, it will go through a subcooler and will go to the low pressure column as the reflex to the low pressure column. Okay, and talking about the subcooler, another stream is the waste. It should be the waste gas from the top of the low pressure column. We'll have heat exchanger with the liquid from the main condenser, and then goes into the main heat exchanger, and will be heater exchange and be warmed to normally ambient temperature and go out of the heater exchanger. Also for the liquid oxygen, after it is withdrawn from the main condenser, it should be a pump here, right? With the pumping to get the pressure you want to get, and goes into the main heat exchanger and be warmed to ambient temperature. And besides the code box of the main of the pressure column and the low pressure column and the main condenser, you can see a small symbol on the actually another column, crude argon column on the right. You can see this column is for argon make. You can see, and there's a stream from the low pressure column withdraw and send into the crude argon column, the bottom of the crude argon column. Normally, the content of the oxygen is about 19%. And it's mean about almost about 10% argon, the crude argon, will be sent into the column. And after the distillation, the pure argon, maybe several ppm, the content of oxygen with the argon will be produced and mixed to, it's liquid argon mixed to the tank. And for another stream, you can see from the bottom of the pressure column, there's a stream goes into the condenser of the argon column to make heat exchange with the argon column, argon condenser in the column. And after that, to back to the low pressure column. Yes. Actually, yes, that's all. That's the main process of air separation. And several parts. One is MAC. One is pretreatment. One is expander. And including main heat exchanger, low pressure column, main condenser, subcooler, and argon column. All of these will be assembled in a cold box. That's a typical configuration. Okay, that's all.
Nice to have your explanation related to the process. And there was a time that a person asked me if the columns in air separation units were squared columns and why it was squared columns. And I told him that in fact what he see in the field is just the shell of everything that's inside the cold box. And the square column that you see in the field is a box where you have inside the column that is cylindrical and all these equipments like main exchanger, lower column, high pressure column, and etc. So sometimes people miss if the squared column is in fact a distillation column, but it isn't.
Okay.
And when you will start a process simulation related to air separation, you need to include the compressor and pretreatment, or you just consider the streams that get to the heat exchanger and it's going out from the heat exchanger in the product.
Oh, you mean when doing the process simulation, right?
Yes.
Actually, you can do both, but at least you need to include the column and the heat exchanger. And for the compressor, like for the MAC and the pretreatment, you can exclude from the simulation because you can know the stream, how much need for the column. And for the MAC, you can just simply put the data in like a spreadsheet, you can calculate. Actually, for the MAC, you do not need to put all the things in the simulation. For just putting a spreadsheet, it's enough. So for me, I will just only include the exchanger and the column in the process simulation.
Okay. Nice. Okay. And which you talked about the hazard related to the main condenser, and it can be an issue during operations. And other kind of advertisement you could give it to people that starting simulating cryogenic system, air separation. In your point of view, it is easy, or there is something specific that you should care about?
You mean when you are operating a separation, right?
We can talk about operation, but also about the process simulation. It's a simple column, or is there something that the chemical engineer should, or I cannot forget about this to convert my column, for instance?
Okay, let me talk about first for the process simulation. Maybe some point you need to care about, right? The first, you need to know what's the input and what's the output you want to get for the simulation. And most of them you need to care about the purity for the product. You need to know what's the pressure, purity. Like, and the product slate, which kind of the product you need. GOX, gaseous oxygen, or gaseous nitrogen, or you need to include the liquid oxygen, or liquid nitrogen, or liquid argon. This is a very, how to say, very, at least you need to know about this input or output. And further, you need to know the column. Actually, the simulation is just a simulation, but you need the column. What the column really can do or cannot do. So at this time, you need to check if you change a little bit more for the existing working column, you need to check the pressure job. It's very important. For less, it will impact the power. And for more, maybe it cannot work if you make more flow inside of the cold box. And another important thing is the main heat exchange. Actually, for the general calculation, you just need to process, you just need to calculate the simulation on your any like HiSys or Unisim, the software, the simulation software. And actually, the heat exchange, the performance, it depends on different vendor, you know. So you need to make sure the data is matched with the vendor. Maybe sometimes you need to verify the vendor informations or other things you need to check. Otherwise, actually, your simulation is just a simulation. It cannot apply it into a real plant. Okay, that's my understanding and maybe some advice for the process simulation.
Harvon, based on the simulation you do, what kind of deliverables do you develop for the plant design?
Sure. No. Actually, for air separation, it will not too much product you can produce. Normally, it will only 3, right? The oxygen, and the nitrogen, and the argon. This is the product.
I mean, related to engineering documents. Which engineering documents you develop to have the the company be able to construct or to erect the plant in the field? What is the role of the chemical engineer? He must do the process simulation, but get the results and transfer that for some engineering documents. Which kind of documents do you develop?
You mean which kind of the documents do this process simulation output, right?
Yes.
Oh, I see. The product slates, just I mentioned. And another very important is the power consumption. Yes, it's very important because when a plant is running, you need to optimize and lowest the power to fulfill the product requirements. And another thing is the cooling water to cool the compressors. Normally we have 2, this is 2, and one is the product and another is power. Okay.
And about operations, do you have experience with operations? Can you give me some advices for those that operates cryogenic plants?
Sure. I'm focused on design, but I have shipped to a lot of plants to commissioning the startup or the optimize. And my advice for the operation is you need first priority, you need to care about the safety related shut point or shutdown set point and the critical parameters like the main condenser level and the purity like the CO2 or hydrocarbon. After that, in the normal operation, you need to care about the pressure. Another very important things, you need to check the historic trend. When you are operating a plant, you need to check the pressure. If any change from day to day, and if you have no remote indication, you cannot check the history on the computer. You need a routine check to the site and record the changes, because sometimes it changes very late, but after time, someday it will make a shutdown or make a broken of a machine. It's very important. Okay.
And you mentioned that you work not only in the ops, but also doing commissioning and supporting, doing troubleshooting. What changes from the chemical engineer that work in the ops and when you need to go to the field to solve problems? What is the difference? There is any?
Yes. How to say? Actually, it's different phase. You know, for the design, it is on the face behind, on the face in front of the commissioning. You need a design first, and then you need a commissioning and startup or optimize, and you need to take care and focus on the power calculation, focus on the pipe size when you are doing design, and you need to focus on the design, like you need to add a valve, and you need to know how to control a valve or how to control a compressors, and it's different when you are on site. If you are on site, the focus will transfer to the plant commissioning or adjust or optimize, like you are finding a temperature is changed, it's unnormal. So you need first you need to check maybe the temperature element, if it is installed correctly on the site. And then you need to compare with the design data, and maybe you need to do a further calculation and to decide if it is okay or not. So it's not, you need to use your design experience to tell what's the gap, because sometimes a temperature is showing things okay, actually it's not. So it's same as I just mentioned. You need to check the historic trend when you're doing operation, because it's very important to tell you what is correct and maybe it's not. That's a difference.
And
okay,
what you have learned during the...
You are mute, Jeff.
Oh, sorry. What you have learned during commissioning and troubleshooting that helped you to do a better design?
I think a lot of, because when you are doing design, actually most of the time you are facing a join, right? Just a join. It's not real things. And when you are on site, it's a real equipment. When doing design, like the compressor, you are joining a compressor symbol on the join, and you join a anti-surge line with a valve, or you just join on the pictures. And when you are on site, when you are doing the MAC or other compressors surge test, it's totally different. So it is when the compressor is surge, right? It's totally will shock you by a big machine and with big vibration. So it will give a big and deep impression. When you are doing design, you know how important the valve is, or how important the set point you need to write down in the drawing. Then all of the things like just it will always let you know you need to put what's the important things on the drawing, and you can tell from the commissioning experience which is important and which on the drawing is just maybe just showing you can save your time and do not waste too much time on that point.
In my content, I always share with people subjects related to process simulation, piping instrumentation diagram, and also I talk about process data sheet for equipment, for instrumentation, and for control valves, and etc. How important is to the chemical engineer know this kind of subject to work with plan design?
Sorry, what's the design for instrumentation?
How important is to the chemical engineer knows about piping instrumentation diagram, about process data sheet for equipment, process data sheet for control valves, etc., and process simulation?
Yes. You mean how important, right?
Yes.
Actually, it's also I mentioned it before. The process is the core of the air separation, and all other functions will refer to your PNID or your data sheet to do the deep design. So your input to other functions is always very important, like the valve spec. Actually, instrument just verify and give your feedback, and finally you need to get the flow requirement to the valve. And how can you tell the flow requirement? Maybe it's from the process simulation, or sometimes some valve is not related from the process simulation. It's maybe from the compressor information, and you need to collect these informations from maybe from the vendor or from the process simulation, and you need to depend on your experience how much margin should be put on the valve spec. And others for the maybe like the pipe size, you need to know what's the pipe size or what's the velocity of the pipe and what's the flow it will be, or what's the flow it will change. It's important. Sometimes you think it's a normal condition, but maybe at some different process, the flow will change. It will maybe double. You need also consider in this situation, the process cycle also should be worked. So it's very important.
But
Okay.
Harvon, I would like to ask you now, what you learned during your job that you think that you should have learned during your chemical engineering course?
Actually, in current social, the chemical engineering is not a fishing job, you know. But for me, I'm very proud of this career, of this job, of this position, because the chemical engineering teach me that you need to be very careful. Be very careful when you are preparing any document like PNID or valve process data or pipe size. And it's the whole system. You can thinking about the whole system and from the very beginning to the end of a plant. You will have a totally thought when you are doing a thing. That's very big things for me. It's very good to me, and I feel very good when my design finally it will come to a real plant and it's running and the plant is earning money for the company.
Guys, I'm here with Harvon, and please let us know where are you from, and if you have any question, just let me know because I can get the chat here. It is at my site, and I can address some questions to Harvon. Harvon, what do you recommend people to learn to increase their chance to work with plant design?
You mean increase the chance, right?
Yes.
For graduates?
To work with plant design.
Okay, to work with plant design. I think when you are working, you can thinking more about how to do or how other persons is doing for the plant designs. And most of the important is for process design. You need to know the input, the output. We just talked in the process simulation. You need to care about of these things and remember in your mind. And at that time, you need to do some calculations and the standards, you know, for the chemical engineering, they are always a requirement. Whatever an international requirement or a country requirement, you need to know and be familiar with the requirement. That's very important.
Okay, we are going to the end of
Jeff,
this meeting.
you are mute again.
Oh, it is my first time doing the interview in the meeting in the Teams. I did the first time in message. It was not good because I didn't sound from my guest, and the next one was in Zoom. It was okay, and now let's see how it will be in Teams if people will like this.
Okay.
Just to let you know, we had people from Angola, Africa, Indonesia, Malaysia. We also had from Nigeria, so Philippines. A lot of people around the world with us today.
Okay.
And if we don't have any question there, I would like to know what would be your last message for people that are starting with chemical engineering and plant design. What is your last message? What you would say to him to encourage him to work with chemical process engineering and plant design? Are you listening to me, Harvon?
Yes. Yes.
I have a question here. The question is, what skills should I invest more to get, and what is the best way to acquire them in chemical engineering?
Sorry, I cannot hear clearly.
What skills should I invest more to get? What is the best way to acquire them to be a great plant designer?
You mean what's the best skills?
Skills.
For plant? Yes. For plant design, I think actually you need to be very good at various point, right? But yes, for the most important, I think it's process simulation. For design, the process simulation is very important when you are doing plant design in process area, because it's the start point and it's the core process point of your design, whatever PID or pipe size. All of the information comes from the process simulation. If you are very familiar with the process simulation, for whatever at the downstream, like on the PID, why this valve size is so big, or why this equipment design like that, you can get answer from the process design. It's very, very important.
I have seen fresh engineers very proud about the grades during the chemical engineering. But what do you think about soft skills? It is important, it's not important. How is the relationship with people that we should care about?
Relationship with people, right? For fresh graduates, right?
Yeah, I want to know if it's important to have soft skills, or it's not important. I just need to be good at technical. What is your advices?
Actually, it's always very important. Always very important for soft skill to work with your colleagues, because you know it's a teamwork for chemical engineering, whatever is separation or other industry chemical. So chemical engineering is for building a very large plant, and you need a lot of engineers, a lot of workers, a lot of people to teamwork together to build a so large plant. So always you need soft skill to work with others, and you cannot work alone, and it's very important. It's do not like maybe a advice statement. You have an idea and you can create by yourself. It's not. It's totally maybe over 100 or over 1,000 people teamwork.
Harvon, I don't have any more questions. Thanks a lot for your time. Thanks a lot. And I would say to people that invest in soft skills, because I believe that Harvon only accepted this invitation because during our work we did a friendship, and he was very kind with me in the office. I was in China, very far from Brazil, and he had the care and patience to share information with me and share information related to China culture and something like that. So it is very important to build friendship everywhere where you go and everywhere you work, because will be the friendships that will help you when you need some assistance in the future. And of course, you need to be good technically, because there is no help if friendship is not only enough if you don't do your part. Okay, so this is my point of view. If you want to have anything to finish this meeting, Harvon, it's up to you, because it was very nice to have you here with me.
Okay, thank you. It's for me, it's very good to share the experience and meet you again via the video. Very glad.
So guys, this is it. It was the live session from today. I hope you like it. And you can join my social media going to my website, jeffersoncosta.com. And in the last week, I may return with another guest talking about chemical process engineering and plant design. So see you soon.